let's talk about Module 9 and let's learn about remainder theorem, factor theorem, and rational root theorem. Target skills or objectives. Pre-test muna.
A few minutes later.
Before we start the discussion about the lesson here in Module 9, let's recall first the previous lesson. We learned about the parts of a division. We have the dividend, the divisor, the quotient, and the remainder. We use this in polynomials. We have the dividend equals the divisor times the quotient plus the remainder. We also learned that when we have the division of polynomials, meron tayong dalawang way. Yung long division at yung synthetic division. At tinanong ko kayo kung alin ang mas madali at alin ang mas dapat gamitin. But laging tandaan na ang synthetic division ay ginagamit lamang when the divisor is a binomial. Now, let's start discussing the lessons on Module 9. Let's consider this. A polynomial f of x is divided by x minus a. By division algorithm, p is equal to d times q plus r. We have this. Take note that x minus a, which is our divisor, ay ginagawa natin ang ganitong solution. We are equating it to 0 para makuha natin yung value ng x. Now, if we are going to use the value of x as a, and through substitution, ito yung mangyayari. F of a is equal to a minus a times q of a plus r. At kung ipagpapatuloy natin ang solution, magiging 0 yung a minus a. At kapag minultiply natin ang 0 sa q of a, matitira na lang ay r, or yung remainder. So, ibig sabihin, when a polynomial f of x, or yung dividend, is divided by x minus a, ang remainder na makukuha natin is equal to f of a. Kaya kapag ginamit natin ang value ng x sa ating polynomial or sa ating dividend, it will result to the value of the remainder. At ito ang tinatawag nating remainder theorem. Para mas maintindihan natin ang ibig sabihin ng remainder theorem, let's have these examples. Example number 1 for remainder theorem. Let p of x equals to 3x cubed plus 4x squared minus 5x plus 6. Use the remainder theorem to evaluate p of negative 3. Dito, binigyan tayo ng value ng x, which is negative 3. So, ano ang gagawin natin for the solution? Let's use the synthetic division for this example. Let's recall the steps. We are taking all the coefficients with the constant as the dividend. We have 3, 4, negative 5, and 6. Now, yung divisor natin is yung value ng x, which is negative 3. Now, let's continue the process. Bring down 3. 3 times negative 3, negative 9. 4 plus negative 9, negative 5. Negative 5 times negative 3, 15. Negative 5 plus 15, 10. 10 times negative 3, negative 30. 6 plus negative 30 is negative 24. Now, we have this quotient. And this is our remainder. Therefore, the remainder is negative 24. So, dito ang focus natin is hanapin ang remainder. Using the synthetic division, we can easily get the remainder. But, let's evaluate directly through substitution. Kung titingnan natin, this is a polynomial equation And pwede nating i-evaluate gamit ang substitution of x, which is negative 3. So substitute x by negative 3, we will have this. And by simplifying, we have this. Negative 3 cubed is negative 27. Negative 3 squared is 9. 3 times negative 27 is negative 81. 4 times 9 is 36. And negative 5 times negative 3 is 15. And finally, p of negative 3 is equal to negative 24. We were able to get the remainder, which is also negative 24. Observe na we can use synthetic division or pwede nating i-evaluate directly through substitution para makuha natin ang remainder. Now, para sa example number 2, kayo naman. If p of x equals x raised to 4 minus 10x raised to 3 plus 2x squared minus 8x plus 5, find p of 10. For your solution, you can use the synthetic division or you can evaluate directly through substitution. Were you able to get these answers? Our remainder is 125. Great job! Let's have one more example for remainder theorem. Example number 3. The expression x cubed minus kx squared plus 5x plus 3 leaves a remainder of negative 11 when divided by x minus 2. Find the value of k. So dito, meron tayong binigay na dividend kung saan may nawawalang coefficient which is k, na kapag dinivide ng x minus 2 ay makakakuha ng remainder of negative 11. So paano gagamitin ang remainder theorem to solve this problem? Let's see the solution. Our remainder theorem ay nagsasabi sa atin that p of x is equal to r. Ibig sabihin, ang value ng x sa divisor ay magbibigay sa atin ng value ng remainder. In this case, meron tayong given value ng x at given value ng remainder. X is 2, remainder is negative 11. Now, isa-substitute natin yung buong expression ng polynomial sa ating p of 2. We will have 2 raised to 3 minus k times 2 raised to 2 plus 5 times 2 plus 3. And we can see na k ang matitirang variable kung saan yun yung gusto nating hanapan ng value. 2 raised to 3 is 8, 2 raised to 2 is 4, 5 times 2 is 10. 8 plus 10 plus 3 is 21. Then by transposition of 21, we will get negative 11 minus 21. And that is negative 32. By dividing both sides by negative 4, k is equal to 8. Therefore, when x cubed minus 8x squared plus 5x plus 3 is divided by x minus 2, the remainder is negative 11. So, the remainder theorem solved the problem. Now, let's consider this. When f of x equals 2x cubed plus 5x squared plus x minus 2 is divided by x plus 2, the remainder obtained is 0. By division, we have f of x equals x plus 2 times q of x plus 0, kung saan mawawala yung remainder. This means that x plus 2 is factor of f of x. That is, f of x is divided by x plus 2. Using long division o kaya synthetic division, o kaya gamitin yung remainder theorem, 0 ang ma-obtain na remainder kapag dinivide natin yung dividend sa divisor na x plus 2. At kapag 0 ang ating remainder, ang ibig sabihin, factor yung x plus 2 ng ating given dividend. So for any polynomial f of x, if f of a is 0 or naging 0 ang remainder, then x minus a or yung divisor is a factor of our f of x or ng dividend. Conversely, kapag yung x minus a is a factor of a polynomial f of x, then yung ating remainder is equal to 0. This explains our factor theorem. Let's get to know more about factor theorem by this example. Example number 1. Determine whether x minus 4 is a factor of each polynomial. A. X cubed minus 2x squared minus 11x plus 12. And B. 2x cubed plus x squared minus 2x minus 15. So, ibig sabihin, gagamitin natin ang factor theorem para malaman kung kanino kay A at B ay factor si x minus 4. Si x minus 4 ang ating divisor, which can be written as x minus 4 equals 0 or x is equal to 4. So, ibig sabihin, ang value ng x natin ay 4. Let's solve for letter A. We can use a synthetic division, but again, what we observed earlier, pwede nating i-evaluate directly by substitution. So, if our p of x is x cubed minus 2x squared minus 11x plus 12, and the value of x is 4, we will have this. So, 4 raised to 3 is 64. Negative 2 times 4 squared is negative 32. Negative 11 times 4 is negative 44 plus 12. By solution, p of 4 is equal to 0. Since the remainder is 0, we can conclude that x minus 4 is a factor of x cubed minus 2x squared minus 11x plus 12. How about for letter B? Let's look at the solution. Again, let's evaluate directly. If p of x is 2x cubed plus x squared minus 2x minus 15 and the value of x is 4, we'll have this substitution. 2 times 4 raised to 3 is 128. 4 squared is 16. Negative 2 times 4 is negative 8 minus 15. And by solution, p of 4 equals 121. Since the remainder is 121, not 0, therefore x minus 4 is not a factor of 2x cubed plus x squared minus 2x minus 15. This is how we use the factor theorem to determine whether a divisor is a factor of the polynomial. Let's have another example. Find the value of k for which the binomial x plus 4 is a factor of x raised to 4 plus kx raised to 3 minus 4x squared. So dito, gagamitin natin ang factor theorem para malaman natin ang value ng k na kapag binuo natin ang polynomial, ay masasabi natin that x plus 4 is factor nito. Let's look at the solution. Using the factor theorem, binigay sa atin that the value of x will yield our remainder to 0. So, given natin is the value of x. Here, x is equal to negative 4. Now, let's substitute it to the given polynomial. Negative 4 raised to 4 plus k times negative 4 raised to 3 minus 4 times negative 4 raised to 2 equals 0. By simplifying, negative 4 raised to 4 is 256. Negative 4 raised to 3 is 64 times k. Negative 4 raised to 2 times negative 4 is negative 64. Now, 256 minus 64 is 192. By transposition, negative 64k is equal to negative 192. By division of both sides of negative 64, k is equal to 3. Thus, the binomial x plus 4 is a factor of x raised to 4 plus 3x cubed minus 4x squared. This is how we use the factor theorem for this example. At para sa last theorem natin for this module, we have rational root theorem. The possible rational roots are formed as positive or negative p over q, where p is a factor of the constant term and q is a factor of the leading term. Tingnan natin yung example para mas maintindihan natin ang rational root theorem. Find the possible rational roots of the equation 2x cubed minus x squared minus 9x minus 4 equals 0. Let's look at the solution. Let's list all the factors of the constant term. In this case, it's negative 4. And the factors of the leading coefficient. In our example, it is 2. Now, ano-ano ang mga factors ng ating a sub 0 or yung ating constant na negative 4? We have positive and negative 1, positive and negative 2, and positive and negative 4. These are the possible values of p. Ano naman yung mga factors ng a sub n or yung leading coefficient na 2? Meron tayong positive and negative 1 and positive and negative 2. These are the values of q. Next, we divide each factor of p by q para makagawa tayo ng fraction na p over q. Ngayon, paano natin malalaman ang initial possible rational roots ng ating example number 1? Kung titingnan natin, meron tayong tatlong factors of a sub 0 or yung ating constant, at meron tayong dalawa na factors ng ating a sub n or yung leading coefficient. Ang gagawin lang is multiply those factors at makukuha natin yung initial rational roots. So 3 factors ng constant times 2 factors ng leading coefficient, we will have 6 initial rational roots. Ngayon, paano natin siya kukumpletuhin? Isa-isahin natin. 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, and 4 over 2. These are the initial rational roots ng ating example number 1. Now, let's simplify para makuha natin ang possible rational roots. 1 over 1 is 1, 1 over 2 is 1 half, 2 over 1 is 2, 2 over 2 is 1, 4 over 1 is 4, and 4 over 2 is 2. Take note, meron tayong mga naulit na value, which is the positive and negative 1 and the positive and negative 2. So to simplify and to have the final answer, isa na lang ang isusulat natin for the possible rational roots. These are the positive and negative 1, positive and negative 1 half, positive and negative 2, and positive and negative 4. These are the possible rational roots of our example number 1 using the rational root theorem. Let's have another example for rational root theorem. List all the possible rational zeros of the equation f of x equals 3x cubed plus 41x squared plus 121x minus 45. Kung titingnan natin, ang hinahanap ay possible rational zeros. Take note, zeros are the same with roots when it comes to algebra. Rational root theorem can be called as rational zeros theorem. So parehas lang yung gagawin natin kagaya nung kanina. So for the solution, first, we will list all the factors of the constant term and the leading coefficient. In this case, negative 45 yung constant term at 3 yung leading coefficient. Now, these are the factors of negative 45. 1, 3, 5, 9, 15, and 45. Take note, these are positive and negative values. These are the values of p. And the factors of 3 or our leading coefficient are 1 and 3. These are the values of q. Next, we divide each factor of p by q to get our fractions, p over q. Paano nga ulit malalaman kung ilan yung initial rational root ng ating example? Very good. We multiply the number of factors of the constant term to the number of factors of the leading coefficient. So, ilan yung factors ng constant? 6. At ilan yung factors ng leading coefficient? 2. So, 6 times 2, we have 12 initial rational roots. So, isa-isahin ulit natin. 1 over 1, 1 over 3, 3 over 1, 3 over 3, 5 over 1, 5 over 3, 9 over 1, 9 over 3, 15 over 1, 15 over 3, 45 over 1, and 45 over 3. But of course, we need to simplify to get our final possible rational roots. 1 over 1 is 1, 1 over 3 is 1/3, 3 over 1 is 3, 3 over 3 is 1, 5 over 1 is 5, 5 over 3 is 5/3, 9 over 1 is 9, 9 over 3 is 3, 15 over 1 is 15, 15 over 3 is 5, 45 over 1 is 45, and 45 over 3 is 15. So these are the possible rational roots for example number 2.
Let's recall the different theorems dito sa ating module. We have remainder theorem. When a polynomial f of x is divided by x minus a, the remainder is equal to f of a. We have factor theorem. For a polynomial f of x, if f of a equals 0, then x minus a is a factor of f of x. Conversely, if x minus a is a factor of a polynomial f of x, then f of a is equal to 0. Then lastly, the rational root theorem, where the possible rational roots are formed as positive and negative p over q, where p is a factor of a constant term and q is a factor of the leading term. Now, it's your turn. Practice exercises.
A few minutes later.
Assessment time. Please answer post-test and additional activities. Thank you, learners, and thank you, everyone. Stay safe. Bye.